Alright, this lesson is on chapters section 5.1 and 5.2. We're going to talk about polynomials. The first thing we're going to do is classify the polynomials. So, for instance, let me give you some examples. Let me get my pen. 4x plus 5x squared minus 8, that's a squared. 2x cubed plus 3x squared minus 4x plus 5. 6x squared minus 3x to the fourth plus 2x minus 6. Okay, these are three different polynomials. A polynomial is defined as a monomial or sum of monomials. And a monomial is a real number or product of a real number and a variable. So basically, 4x is a monomial, 5x squared is a monomial, negative 8 is a monomial. When you put them together, you get a polynomial. Some polynomials have special names. Let's first talk about the degree. The degree is the highest exponent in the polynomial. And when you write the polynomial in standard form, the number with the highest degree has to go first. So in standard form, this polynomial would be 5x squared plus 4x minus 8. This is called a quadratic polynomial because the x squared means quadratic. It has three terms, 5x squared, 4x, and negative 8. What else do we have to talk about? Standard form, terms, and its degree. Its degree is 2, the highest exponent in the polynomial. So, it's a quadratic polynomial, degree of 2, 3 terms, and it's in standard form because the highest exponent's going first. This one's already in standard form, 2x cubed plus 3x squared minus 4x plus 5. It has 4 terms, 1, 2, 3, 4. Its degree is 3, because that's the highest exponent, and it's called a cubic polynomial. This one we would have to put in standard form. It also has 4 terms. Its degree is 4, and it's called a quartic polynomial. Now that's as high as we go. Once we get up to 5th degrees, we don't really have names, and nobody would really ever call this a quartic polynomial. They just call it a polynomial, but it has degree of 4. So that's what you need to know about classifying polynomials. Now we're going to talk about the real stuff. The first thing we're going to do is factor polynomials. Up until now, all we have factored is quadratics. But now we're going to say, what happens if it's not a degree of 2? What happens if it's a degree of 3? And we've done some of these. For instance, all 3 of these have a GCF of x. So when you factor out an x, you end up with a quadratic. But it's good practice for us. So you should try these and see if you can factor them, and then I'll show you the answer. So pause the video and try them, and then come back and see if you got them correct. That's the first one. The second one would be, now notice I'm doing this in 2 steps. A lot of you guys try to skip this middle step. And then this one would be 3x The only way to get 3x squared is 3x and x. The only way to get 1 is 1 and 1. I just have to figure out the signs. I need it to equal a negative 2. So 3 times 1 is positive 3, but if I put a minus here, then it's 3 times negative 1, which is negative 3, plus 1 gives me negative 2. So that's writing all of these in factored form. Now, let's make all of these equal 0 and find the roots. The roots of this one are x equals 0, x equals negative 6, and x equals positive 6. Notice there are 3 roots, and it's a degree of 3. For this one, x equals 0, x equals negative 4, x equals negative 4. Now, you're thinking, well, those are the same, so this one only has 2 roots. Well, technically, because of this 3, it must have 3 roots. So what we say is that the roots are x equals 0 and negative 4 with a multiplicity of 2. Multiplicity of 2. And we're going to talk in class about what the multiplicity tells us about the graph. But just know that it still has 3 roots. It just so happens that 2 of them are the same. This one, 3x equals 0, so x equals 0. 3x plus 1 equals 0, so x equals negative 1/3. And x equals 1. So the 3 roots here are 0, negative 1/3, and 1. So we have now found all the zeros. The other thing I want to talk to you about is writing a polynomial given the zeros. So if I told you that the zeros were 0, 6, and negative 6, would you be able to write the polynomial? So let's talk about how to do that. First we're going to talk about the zeros. So this is like after it's factored, what are the zeros? So you would say x equals negative 1, x equals 2, x equals 3. Keep this in mind, because on the next slide, let me write that neater. X equals negative 1, x equals 2, x equals 3. On the next slide, I'm going to give you this, and you're going to have to tell me that. So think about what we did to get these as the roots from these factors. And again, here, this would be x equals negative 1, x equals 1, x equals 2. Here we would have 0, negative 2, and negative 3. So now what we're going to do is write, the directions are, write a polynomial function in standard form with the given zeros. So in order to have a polynomial with zeros of 5, 6, and 7, that means we would have had x equals 5, x equals 6, x equals 7. That means the factors must have been x minus 5, x minus 6, x minus 7, right? Because if we set that equal to 0 and draw the t, this is what we would have gotten for answers. So this is the polynomial. The problem is it's not in standard form, it's in factored form. So we have to review how to put this in standard form. So what I'm going to do first is I am going to FOIL the first two. So the first is x times x, which is x squared. Outside, negative 6x. Inside, negative 5x. Last, plus 30. Combine like terms. And then I'm going to multiply that by x minus 7. The last one. X squared times x is x cubed. X squared times negative 7 is negative 7x squared. Negative 11x times x is negative 11x squared. Negative 11x times negative 7 is plus 77x. 30 times x is plus 30x. And 30 times negative 7 is negative 210. Go back and watch that again if you don't understand where this polynomial came from. I'm still not in standard form yet. I still have to combine like terms. So the x cubed doesn't have any like terms. Negative 7x squared and negative 11x squared is negative 18x squared. 77x and 30x is 117x. Or 107x, sorry. Minus 210. So it's in standard form, has 4 terms, and if I were to solve this polynomial, if I were to put it on a graph and see where it crosses the x-axis, it would cross at 5, 6, and 7. Okay, let's try another one. Try 23 right now. You try it, and then pause the video and come back and see if you did it correctly. So the factors are x minus 1, that's where x equals 1 comes from, x plus 1, that's where x equals negative 1 comes from, and x plus 2, that's where x equals negative 2 comes from. If I FOIL these, I get x squared plus x minus 1, which simplifies into x squared minus 1 times x plus 2. X squared times x is x cubed. X squared times 2 is plus 2x squared. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. There are no like terms. It's a third degree polynomial, otherwise known as a cubic, and it's in standard form. I don't have to do anything else. Alright, last one and then I'll let you go. Number 24. That one's pretty tricky. So the first two factors are x and x minus 4. Those should be pretty easy for you to understand where the 0 and the 4 comes from. For x equals negative a half, you have to figure out what they did to get this as a root. So basically, you want to make this equal 0. So multiply both sides by 2 and add 1. This was the factor they had in order to get this root. So your third factor here is 2x plus 1. So if you can't figure out what the root is, set it equal to x and then make it equal 0. So now if I distribute the x, I'm only going to distribute it through one set of parentheses. So I'm going to have x squared minus 4x times 2x plus 1. X squared times 2x is 2x cubed. X squared times 1 is plus x squared. Negative 4x times negative 2x is minus 8x squared. Negative 4x times 1 is negative 4x. Combine like terms. And this is my third degree polynomial in standard form.